Okay, standard 2.6 is explain the physiological processes involved in disorders of the skin, such as burns, cuts, diseases, and skin cancer. First thing is, what are the symptoms of each of the 4 degrees of burns? Describe the appearance, what layers the skin has gotten to, and how it feels. We're going to go through each one of the 4 degrees. Let's start with the first. Thinking about the burns, talking about the layers. A first degree burn is only going to go through the first layer, the epidermis. The second degree burn is going to go to the second layer, the dermis. Make sure you say the names. The third degree burn is going to go to the hypodermis, the third layer. A fourth degree burn is going to go below that to muscle and bone, to the fourth layer, you could say. Although it's not the skin anymore, it's muscle and bone. So, first layer, first degree, second layer, second degree, third layer, third degree, fourth layer, fourth degree. Talking about how far down into the skin it has gone. So first degree is just up here. Second degree has gone into the dermis. Third degree has gone all the way down. Fourth degree is going to go below that. So first degree burns. There's symptoms. We're going to get blisters. You can see that in this picture here, right? There's a little blister here and there's some liquid in there. It's going to be warm. It's going to be red. And it hurts. So we have blisters. It's going to be red. And it's going to hurt. And it's going to be warm. And dry too. A dry burn, unless that blister pops and releases fluid, but mostly dry, right? Can your body repair the damage? Yes, we can. The epidermis is damaged. Stem cells are going to make new keratinocytes, right? Thinking of standard 2.1. Keratinocytes in here are going to start growing and repair that gap and close that. It's definitely repairable. Second degree burns. Sorry, let me shrink this. Second degree burns. What are the symptoms? You could just take a look at this picture, these two pictures, right? It's gone down into the dermis, right? And we have a bigger blister. And it's different. It's going to be, now it's going to be bigger blisters and red and pink, right? Pink skin too, because it's gone further down. It hurts. So this black stuff that you see here is actually just a pile of skin. It used to be all over here. This is a huge blister, and it popped, and the skin got rolled back. I know it looks gross, but it was red and pink too, and we have huge blisters. Can we repair the damage? Absolutely, because fibroblasts can make more collagen and other fibers, and we can eventually repair that. It's not total loss. The last one is third and fourth degree burns. Right? The symptoms are going to be pretty much the same. It's going to be black, dark brown, or white. Okay, so this picture's gross, but you see white because it's burned down that low. There's black, and oh gosh, it's gross. Dark brown too. All those symptoms are going to be of third and fourth degree burns. We're not going to feel it. So looking at this picture, the burn has chopped off burned away all of the skin. All the skin's gone. There's no nerves anymore. Nerves would be right here and reaching to the top, and they'd feel pain. They're gone, cut out. So we don't feel anything. You look at this hand, this really gross hand, and you're like, huh, that's interesting, but you don't feel it. And then you look at your second degree burn, and you're like, oh my gosh, that's so painful. But a third and fourth degree burn, no feeling, which is actually worse. Can your body repair the damage? So this huge hole is going to be really difficult for our body to repair. There's a lot missing, and we can't put back a lot of stuff. But we can perform a skin graft. So we'll grow skin on another area, make a little circle, and slap that on there, and heal the wound. So a skin graft is necessary. So this is why we have burn units and burn clinics in hospitals, so that they can do skin grafts and other things to save patients who have burns this bad. Symptoms again, black, dark brown, white. We can't feel it because the nerves in the dermis, right here, have been destroyed. Next thing, based on what you know about the skin regrowth process, what would be more difficult to repair? a shallow cut that covers most of the arm, or a thin cut that goes deep into the skin. Explain using your knowledge about how the cells work to repair the skin. So thinking about skin repair, when we get a cut, epidermal cells have to migrate down the edges, right? If they have to move really far, it's going to take a really long time for them to fix the wound. So if my cells start all the way over here, and they have to migrate, this is going to take a really long time. It's going to take forever for this migration to happen, and my wound is going to take forever to heal because the epidermal cells have a really long way to travel. In a big shallow cut, epidermal cells have to move far because we've cut off a huge area, so there's a huge hole they have to walk across. So it's going to take longer to repair. In a thin deep cut, cells don't have to move very far. If I have a really thin slice, epidermal cells are going to be right there and ready to go down. So if the cells don't have to move very far, the cut can be repaired faster. And if you think about it, losing a big section of the epidermis is really bad because that's our protection from losing water and a protection for bacteria and viruses getting inside of us. And we're going to have a huge hole in our armor that we have to the outside world, and that's going to cause problems. So, which is more dangerous? A thin, shallow wound, a shallow cut, because epidermal cells have to migrate farther, and you have a big hole in your barrier. What happens when melanocytes work too much? What happens when they work too little? Okay, so melanocytes, if you remember, make melanin. Melanin colors our skin. If my melanocytes are not making very much, enough melanin, my skin will be lighter. If melanocytes are making too much melanin, my skin will be darker. So, we're talking about right here. We can switch these two too, sorry. Alright, if melanocytes are making too much melanin, my skin's gonna be darker. So any mole that you have, your melanocytes are overactive there, and there's a dark patch because melanocytes are making more melanin. So anytime we're talking about color of skin being different colors, melanocytes are active there and making more. If melanocytes aren't making enough melanin though, we're gonna have the opposite. Our skin's gonna be lighter. So in this person right here, you can see that their melanocytes normally are producing enough melanin, so their skin is black, right? But their melanocytes stop working, their skin loses that color because their melanocytes aren't functioning correctly. So their skin is going to turn lighter. This is called vitiligo, which people thought which Michael Jackson was said to have, and he might have or might not. But again, melanocytes aren't making enough melanin, my skin's going to be lighter. And if we're talking about cancer, I won't have as much protection here, right? I can get sunburned easily here, versus in this area of the hand, right? I have my melanin protecting me, I won't get burned, but on these lighter areas, I'm going to get burned. Here, I have protection, I won't get burned there, so it's fine. What fiber snaps and causes stretch marks? So elastic fibers give the skin its stretchiness. That is why we can grab our skin, tug it, and pull it, and it will snap back into place. In this picture right here, the elastic fibers are these purple ones, right? The collagen is going to be these brown ropes, strong ropes. The elastic fibers are the purple ones. If we stretch an elastic fiber and it snaps down the middle, our skin is going to lose that stretchiness, and you're going to get a stretch mark. So these, what we would consider ugly or just things that we don't like on our skin, right? Stretch marks happen because elastic fibers snap. And we don't have that stretchiness, and the skin loses that. What cells build the dermis? How do these cells relate to wrinkling? So, in the dermis, if we're thinking about skin repair, we know fibroblasts are going to make collagen, right? And repair that dermis. So, fibroblasts build fibers. Since the dermis is made mostly of fibers, fibroblasts build the dermis. Fibroblasts build the dermis. If fibroblasts stop working, fibers won't get made correctly. So look at this younger skin right here. A young person, we have lots of working collagen. You can see in this picture, let me zoom in for you, all these lines, right? That's all the collagen in there. If fibers aren't getting made correctly, wrinkles will appear because the structure of the skin gets warped. Let me show you what I mean. Take a look at this picture of older skin. The collagen fibers aren't as many, right? There aren't as many of them, and the skin loses its structure and starts getting these wrinkles because it's not working as well as it used to. We need the collagen, so we have this nice, young-looking, skin that is perfect, I guess you could say. So fibroblasts build fibers in the dermis. Fibroblasts build the dermis. And fibroblasts stop working, we won't make fibers, so we'll get wrinkles. What happens when mast cells don't work? What happens when they work too much? Mast cells sound the alarm when something gets in the skin. If you remember connective tissue, mast cells sound the alarm, say, oh my gosh, something's wrong. So if you're looking at this picture, this thorn has just sliced into the skin. The mast cells, these green ones right here, are saying, oh my gosh, something's wrong, and releasing chemicals that cause the body to react and say, we've got a problem. If mast cells aren't here, my thorn will chop into my body, and bacteria and viruses will come with it and start to party, reproduce themselves and grow here. And it'll take me a while to go and fight them. I need mast cells to sound that alarm, so my white blood cells come in and start eating things fast. But if they work too much, we're going to have lots of inflammation. So let's do this. If they work too much, they're too sensitive, hypersensitive. We're going to have inflammation. Inflammation is when we get red and irritated. Our skin gets red and irritated and maybe pimply too, right? Is from inflammation. You look in this picture, right? It's darker red here. We have fluid that gets put into the area, and then the skin will swell up into a bump. Inflammation is irritating and painful. We don't want mast cells to be too reactive because we don't want constant inflammation. It's not fun. It'll also just be bad because our body is wasting energy on things we don't need to fight necessarily. So, mast cells don't work. We're not going to fight a bacteria as fast because we won't sound the alarm. If they work too much, we're going to have lots of inflammation, which will be irritating and painful because they're too sensitive. What cells cause inflammation? Why is inflammation a good thing? We just talked about this. Mast cells cause inflammation. They sound the alarm and say something's wrong. So your body initiates the inflammatory response to combat pathogens. So a thorn, a splinter, chops into our skin. Mast cells are going to react and release signals. It doesn't have a good picture of mast cells on here. We could pretend this is one, but it doesn't look like it. The splinter gets into our skin, mast cells react and sound the alarm. And what happens is we release fluid to leak out of these capillaries right here. Fluid's going to leak into the area and make this big circle and cause swelling, make our skin form into a bump right here because we're injecting fluid there, right? The fluid is going to help white blood cells come out of the capillaries and attack invading pathogens and consume dead and infected cells. So I sound the alarm so that I get all this fluid and white blood cells come out of my capillaries and start eating things, bad things that I don't like. That's why I want inflammation, number one. Number two, the temperature is going to increase because I have warm blood here. And that's good because heat suppresses bacteria growth. You cook something super hot so we can kill bacteria. Our body is going to increase our temperature just a bit so in this area so that we can kill bacteria and make it harder for them to grow. It won't be perfect, but it'll work really well because bacteria can't stay in that temperature change though, like we can. So inflammation is good because it helps fight bacteria. It makes it too hot for bacteria to grow, and it helps white blood cells come to the area. And mast cells are the ones that cause inflammation. What causes acne? Acne is going to be because of sebaceous glands. They get blocked. Sebum builds up and we get inflammation. Inflammation we just talked about is when our skin gets red and swells up and it's irritated. So in acne, we'll block the hole that sebum comes out of gets blocked. We get a plug, and the sebaceous gland is going to release sebum into the area, and it's just going to start accumulating and making more and a bigger and bigger blob of sebum, and that's going to make a bump, right? And we'll have inflammation on top of that, which will make it red around the area. If the pore is fully blocked, it's going to be a whitehead, so we'll have a lot more fluid, right? And we're going to get a bigger bump. It'll be a whitehead. If the pore is partially blocked, we're going to get a blackhead, right? Which is smaller. It's not as clogged right here. Eventually, the sebum bursts out of the skin, which you all know if you've ever popped a pimple. So what causes acne? Sebaceous glands, talking about sebaceous glands and sebum. Sebaceous glands, the pores of sebaceous glands, sorry, how's that? The pores of sebaceous glands get blocked. Sebum builds up and causes inflammation. Fully blocked is a whitehead. Somewhat blocked is a blackhead. And that is the end of 2.6, explain the physiological processes. Good luck.